This is Nadia. I'm going to talk about optimizing for performance in Python. So as I mentioned before, I've been a backend software engineer at Divvy Cloud for 2.5 years. A little background about what we do in Divvy Cloud. We help our clients reach their compliance goals by providing an interface for them to see all of their cloud resources, whether it be AWS, Azure, GCP. And from there, they can take action on those resources and mitigate compliance issues. So we identify risks and take action and mitigate their issues from there. At Divvy Cloud, we mainly use Python, and I think everyone here either works in Python or is interested in Python, and that makes a lot of sense. It's gotten a lot more popular in the last few years for a lot of reasons. It's a flexible language, it's easy to learn, it's easy to read. You can use it for machine learning, data analysis, web applications, and programs. But a complaint that I do hear a lot about Python is that it's slow. So I want to talk about that a little bit. So why is Python slow? So in Python, multi-threading is difficult, and this is due to the global interpreter lock that doesn't allow for concurrent threads. So I don't think you truly can even really get true concurrency in Python. You can get close and you can play around with it, but multi-threading is not there as a concept as it is in other languages. In addition to that, it's a dynamically typed language. This means that it's not compiled. It's interpreted at runtime, so the types of variables are not known until the program is actually run. So given these two things, Python is not naturally a fast language like maybe C or Java are, but we can work around that. We're not doomed to live with slow Python code forever. So what I'm going to talk about is recently at work, I was tasked with optimizing an identity access management policy analyzer. I want to talk about my experience kind of debugging and like figuring out what was going on and how I was able to make this thing faster. So a little background on the problem. In Amazon Web Services, they have this thing called IAM, Identity Access and Management, and it basically decides if a user has access, or if it will deny access or allow access for a user or a principal. And this complicated graph that you can see is kind of how it makes these decisions. Is it going to allow it or is it going to deny it for certain resources? And the way that it does this is with policies. And on the right, I have an example of a policy right here. So a user could have one policy like this or a bunch of policies, and that is called a policy stack if you have a bunch of policies added onto one user. So looking at this policy, if we look at the action section of the JSON right here, you see 3 items: IAM get star, IAM list star, IAM generate star. So that may look like action. Actually, those stars unpack to become several actions. It's matching everything that starts with IAM get star. So that's IAM get role, IAM get user, IAM get group. And then so this particular policy actually unfolds into being much bigger than what it looks like. And on top of that, you can have multiple policies at one time. So on this analyzer, some of the slowest policies were taking upwards of 300 milliseconds to analyze. And for our clients, we scale up for them, that turns into minutes. And so if you're our client, you don't want our little analyzer to run for minutes. You want it to run for seconds or less. So what can we do about it? What can I do about it? So the tools I used for this, the first one was a timer. Obviously, I need to be able to track how long each thing was taking, and if I'm getting faster, am I getting slower? And luckily, Python has some timers built in. These seem to be the 2 most popular and pretty basic to use: time and time it. I use time, but I think they're both pretty similar. It's as easy as importing time and then instantiating the before and after whatever piece of code you want to run, and then finding out how long it took is as simple as getting the difference of the before and the after value. So a timer is good, but it doesn't tell you much. It really only tells you how long each thing took. And is there something else you can use that will give you a little more information? And in fact, there is. Python has these things called profilers, and the native profilers that we can use are cprofile or profile. And there's a lot of other profilers out there that people have written. I didn't use them, and I think actually cProfile is the most popular one that people tend to use. It's really easy to use. According to the docs, they recommend using cProfile because the regular profile has more overhead, and maybe if you wanted to extend the profiler, it would be a better option, but I didn't want to do that. I just wanted to see what was going on. So what a profiler does is you import it, instantiate it, and then enable it before you want what you want to look at, and then disable it after. And it will give you an output of statistics of each, basically what it ran through and how long each thing took. So super helpful. This is an example I took straight from the documentation, but this is exactly what the output would look like. This is what it looked like for me. So we see 197 function calls, 192 primitive calls in 0.002 seconds. A primitive call is just a call that did not recurse. So looking at this chart, the first column, n calls over here, is the total number of calls. And what I thought was really nifty, down here at the bottom, this last figure, 3/1, tells you that this method recursed. So if you see the /, it means that the method recursed, which is super interesting when or helpful when you're solving for optimization, because recursion is definitely going to be a bottleneck and somewhere that you would want to look at if you're trying to make your program faster. And the next column is total time. So total time it took. Then per call is total time divided by the total calls, this column over here. Then we have cumulative time, another per call, which is cumulative time divided by primitive calls. And the last column actually gives you the file name as well as the line number. So here we literally see read.py line 212. So it really pinpoints exactly where you need to be and how long it's spent there. So looking at this though, this is very similar, and a very similar output to what I saw as well. I just see a bunch of zeros. And I remember thinking, this isn't helpful. Like, what am I gonna do with a bunch of zeros? This took no time. Like, how can I make something faster that took almost no time? But the important thing to remember when you're doing optimization is that these things do add up and every little bit counts. So I saw something similar, like this is like 0.001. So I remember seeing, I think I was seeing 0.016 and 0.013 in a few places. So I narrowed in on those spots and was able to go directly to the line number to see what was going on. And what I found was basically building objects in a for loop is slow. Go figure. So this is kind of a boiled down version of exactly what I saw, but the basic gist, it was like a bunch of methods calling each other, but what they were basically doing was this. It was a for loop that was creating a list comprehension that was creating. So it was literally a for loop, list comprehension, object creation all in one, and it happened 6 times in a row. So it was for loop, 6 times in a row. So this definitely looked suspicious, and this is a lot going on. I was like, for loop, that looks slow. Action creation, that looks slow. List comprehension, that probably is causing issues. Let's see what's going on here. So my first thought was, is there anything about instantiating an object that I can make faster? Can I make, every time it makes a new object, is it possible to tweak it so that each new object happens just maybe like the tiniest millisecond faster? So what I tried was to manipulate the class. I tried to change how the class was being instantiated. And one of the things I tried was a named tuple. So I got the idea from a coworker. He suggested it that they're lightweight. These are fast data structures, faster than dictionaries. And the way that you can use it is instead of instead of making the attribute under the init, like instead of like a self dot statement, you make this named tuple. You can create the object, all right, it's right above it. So I tried this and it did not make anything faster. So this is one of the failures that I ran into. And although I will say that even though this didn't work for me this time, I would definitely look into named tuples in the future because they are a faster data structure. It just didn't help me in this instance. And while I was doing this entire performance thing, I have to say that I think I made the analyzer slower at least 15 times before I made it faster. So definitely with performance, there's a lot of going backwards before going forward. So do not despair if that happens to you, because it probably will. So now what? Changing the structure of the object didn't help me at all. It didn't go faster or slower. So what can I do? So the next thing I thought about was, what about the order of operations? Like, do I really need to have an object being created inside of a list comprehension, inside of a for loop 100 times or 6 times? Can I pull something out and do these in a different order? So basically what I did was I front loaded the object creation. I created all of the objects when the program first ran. So right when the program runs, instead of waiting until it hits these for loops, the first thing it did was create all of these objects. So I basically just kind of like deconstructed what was going on and just moved the order of how everything was working. And I found that it wasn't the objects did not have to were created in those loops. Like it worked, the behavior didn't change when I took them out and made them sooner. So what happened when I did that? It went from hundreds of milliseconds to tens of milliseconds. It was literally 10 times faster. So that was my big win. So basically, what we've talked about so far, for loops are slow, especially nested for loops. If you see nested for loops, that is for sure a red flag. And if you're looking for performance optimization, see if there's something you can do about that. Name tuples are fast. They did not help me in this instance, but definitely something I would look into again, since they seem to be a performative data structure. Object creation also is something to look into, because it does take time. And if there's a faster way to do it, or if you can change the order of operations, which is the last bullet point, see if you can do that to make the object creation faster. And then other things that I want to mention about performance in Python, list comprehensions are faster than for loops. And this could be because that they're not calling append each time, and they're not looking for the list each time. They're kind of already set in their pattern. So these do tend to be faster than for loops. Generators, something else I was looking at when I was looking into smaller changes to make. People are like, generators are an iterator that yields objects one value at a time. And they have a lot lower memory usage and possibly could be a more performant data structure to use. And then unnecessary imports. So this means, like, are you importing modules that you don't need to import? You don't want your program to slow down before it even starts, because it's importing some huge module, some huge library that you don't really need, or that you don't need the whole thing. So that is also something to look into. Maps and dictionaries tend to be, I think in pretty much most programming languages, tend to be a pretty performant data structure. And this is because they can do a lookup. You don't have to read the entire data structure to find what you're looking for. Next one is sets. Sets get rid of duplicates. If you don't less items, especially if you're doing a list comparison, you could potentially look into making the list sets. And the last thing is dunder slots. These also can improve the speed of attribute lookup. This would be used kind of how I use the name tuples. If you want to use slots as a way to create new attributes in a class, it's potentially a faster way to do that as well. Yeah, and then my last piece of advice is to set goals. When I was first given this assignment, my JIRA ticket literally said, make this faster. And I didn't know what that really meant. So I felt like the second somebody put, okay, make this 5% faster, I felt like my brain was able to comprehend that goal more. And it was easier to make small incremental goals, easier to be like, okay, what can I do to make this just a little bit faster before you like really dive into how to make this a lot faster. So definitely making smaller goals to work up to your bigger goal helped me a lot. And then last thing is you will go back. I've mentioned this before, but I'm going to say it again because I feel like it was so integral in my experience. You will go backwards before you go forwards, probably. I feel like with performance, you're going to make it slower before it goes faster, and not to despair about that. So yeah, that's about it for me. Let me know if you guys have any questions.
Awesome. Thanks, Nadia. So we're going to go ahead and open it up. You all can post in the chat if you have any questions. And then also you have a feature where you can raise your hand. And so if you would prefer to just verbalize your question, raise your hand, and then we'll unmute your microphone. So we'll do our best to get to everybody's. We'll go ahead and open up questions for about 10 minutes or so. I think it should be.
I actually don't see it right now either. If
Okay, it looks like, yeah, at the bottom of the participant pane, you should have the option. So Nadia, it looks like we have one question from George Zotto in the chat, if you want to go ahead and answer that one.
Okay, I'm looking because I just saw a bunch come.
Yep, I can go ahead and read it if you want me to.
Yeah, because, okay, yeah. I see it. So it says, apart from Python itself, do AWS or GCP have optimization tools or profilers? Do you mean like I don't know the answer to that, honestly. Do you mean like for code, like just for your code? I'm assuming yes. Yeah, I don't know the answer to that, sorry.
Okay, we've got another raised hand from Nick, who I'm going to go ahead and see if we can mute.
Hi, I was wondering if you could go back to how you sped it up by changing the order of operations. I wasn't clear if you if you reduced the number of object creations or just did it, if you just did it at a different time?
Yeah, that's a good question. So I did not reduce the number of object creations. I did the same amount, but doing it, so they were just trapped in, I think what was happening was a series of loops, and they didn't need to be there because they were going to be created anyway. Like they weren't, it was not necessary for them to be looped through. Like they were, I did the object creation of like the first thing. So those loops were doing they were doing other comparisons to the objects themselves. If I don't know, it's kind of, so they were doing comparisons to object themselves, and the way it was written was it was doing the objects right there in the loops, but what I did was moved it to the very beginning before those loops hit, so they were not kind of like going through loops a second time. If that makes sense.
Looks like the next one we have is from Wade, and he says, how do you structure your order of operations from optimizing performance?
Okay, so for this, I feel like what I'm trying to verbalize is what worked for me here and has actually worked for me since then. Can you hear me? It says my internet connection's unstable. Okay, so kind of what worked for me then and what kind of continues to work for me is a lot of it is taking unnecessary steps out of getting looped through. So if something doesn't have to be, if you need, sorry. Basically, yeah, it's taking stuff that doesn't need to be in loops out of loops. So I think it's sometimes when you're programming, it's easy to start writing a loop and not realizing that you're putting extra work into it that doesn't actually need to be looped through. It can happen before it happens. I feel like that was my number one takeaway from this, and I've caught it a few times while looking at other code in our code base and also writing it myself. And it's also kind of, on top of that, that's kind of also the journey, isn't it? It's kind of like the fun part, and kind of our job is kind of solving these problems. Like what does work? Like, I mean, I think that answer would change also from case by case basis. Like that's kind of when you're looking at something through a performant lens, like how can you change this to make it more performant? Like I don't have the set answer here, but that is definitely something that's kind of the questions we have to ask ourselves when we're trying to figure out how can we make something faster? What here doesn't need to happen here? What here is taking up time? Can I move it? Can I front load it? Do I have to do it at all? Questions like that.
Very cool. Okay, so then another question that we had was from Kyle, and he says, I don't think you talked about it here, but was wondering if you had any experience with multiprocessing or otherwise doing things in parallel you could talk about. I wasn't prepared to answer that. Not really. I do feel like a constant struggle that we have at work is trying to figure out trying to get Python to do concurrency or multiprocessing. And that's not necessarily something that I've worked on myself a lot, but it comes up in conversations, and like I've definitely seen the problems that it can face in Python, but right now I don't have a good story to tell about me conquering multiprocessing.